All right, so this is going to be the second half of the review. So we'll start with number 13. Still, you're going to need your chart. So for 13A, it asks for the probability of more than 120. And remember, z-score is found by doing value minus average over standard deviation. So that gives us a z-score of about 0.57. So since it's more than, we do 1 minus what we read from the chart. Okay, part B is less than 100. So we won't need an adjustment. We'll just read whatever we get from the chart. The z-score is 100 minus average, and then divided by standard deviation. So notice we get a negative z-score here. You always get a negative z-score when this value is less than the mean. But what we read from the chart is 0.1949. And then if we want to go between, we already have the z-score for one of them. So the z-score for 90 would be 90 minus average over standard deviation, or negative 1.57. And we already have the z-score for 100. We can look back to part B. We got z is negative 0.86. So remember, between, you just find both values and subtract them. Okay, so that's number 13. In number 14, we change kind of mode and we start talking about sample size. And so this time you want to make sure you read the test really, really carefully when you take it. So first it asks, is it even appropriate for us to be using the normal distribution for X bar? Notice this is when we have to prove that the list is big enough, that we sampled a big enough size group. And since it's bigger than 30, 42 is bigger than 30, then yes, it's appropriate. Remember that means we're going to have to find a new standard deviation, a standard deviation of the means, if you will. So if you look in your formula chart, that is standard deviation of the whole group, the population, over the square root of n. So this is going to be the standard deviation that I use when I'm discussing the means, okay? The standard deviation of the X bars, that's what that means. All right, so notice in part B it says, if appropriate, find the probability that X bar. So anytime they mention X bar, this is where you know, hey, I need to use new formulas, okay? So we want to go between 53 and 54. So it's going to be 53 minus 52, but then because we're doing X bar, we put it over this. For 54, we do the same. So we don't use the population standard deviation, we use the sample standard deviation. And then we look on the chart, as always, to find these values. So this one comes out to be 0.72. This one comes out to be 1.44. If you subtract the values you find on the chart, you get 0.9251 and 0.7642. Which is 0.601. Can't talk. 0.1609. And then last but not least, we haven't done one like this, but find the 45th percentile. We haven't done percentile yet. So remember, here is where you look for the closest thing to 0.45 on the chart, which if you look at your chart, the closest thing is 0.4483. And the z-score that matches up with that is negative 0.13. So this is where you actually have to try to find the X bar, right? So remember, z-score for this looks like X minus X bar over the standard deviation of the X bars. So then we're just going to plug in what we know. We know z is this. We know the average is 52. And we know the standard deviation of the X bars is this. So it's been a minute, right? But you multiply these and then add 52. And if you do that, you're going to get that x is 51.82. Okay. So a mean of 51.82 would be bigger than 45% of the other means, basically. Remember, this is where you're trying to decide, like, how many samples you're going to take and so on and so forth. This is when usually you have a really big population. All right, let's look at 15. So 15a says, what is the probability that the sample mean is greater? So when you see the word sample mean, then we have to use our X-bar stuff. So we want the probability that the sample mean is greater than 2. Okay, so first we need to find our standard deviation of the X-bars. So that's going to be standard deviation of the population over square root of the n. So we get 0.1302. Okay, so now we want the probability of more than 2, so we need to find the z-score. So it's going to be 2 minus mean over the standard deviation for those means. It works out to be negative 0.184. And then remember, because it's more than, we're going to do 1 minus what we read from the chart. So 1 minus 0.0329, which is 0.9671. Part B, what's the probability that the sample mean is? So again, sample mean is between 2.5 and 3. So we need to find z-scores for both. So value minus average over standard deviation of the mean. And then same with this one. So here we get a mean of 2.0. Here we get a very large mean of 5.84. Okay, so we're going to subtract the 2. Remember, anything bigger than 3.7, I think is what it is. Let me look at my chart. Yeah, anything 3.7 or more just comes out to be 0.9999. And then we're going to subtract off what we get for 2, which is 0.9772. So 0.0227 is what we get for part B. So part C says find the 30th percentile for the sample mean. So like we did in the previous problem, we're going to want the closest thing. The closest thing to 0.3, which is 0.3015, and z equals negative 0.52. So now we're going to put that in the formula. So z equals the value we're trying to find minus the average over the standard deviation. And so if we cross multiply and all that good stuff, you're going to get that x is about 2.17. Okay, part D says, would it be unusual for the sample mean to be less than 2? If you pay attention, you already did part of the work in part A. Now part A asked for more than 2, but we can use the same z-score. We just don't have to do the 1 minus thing. So you could do it all again, or you could pay attention to part 2, but the probability of it being less than 2 was 0.0329, okay? So yes, it's unusual. So be looking for problems where you don't have to figure it all out again, okay? So I just used my information from part A. And then part E, can you tell whether it would be unusual for an individual? So this is where it's different. Just know that you're not going to be asked 2 questions that are the exact same. So it is asking you something different than in part D. So part D was for the sample mean. This is for the individual, which means when you go to find z-score, You do value minus the mean, but then over the population standard deviation, okay, because it's an individual, it's not the means, okay? And notice you get a much different z-score. And if we want the probability of less than that, we just read the chart and it's 0.4207. So notice this is not unusual at all. In other words, it would be very unusual for a large group to have a mean less than 2, but for one value to be weird and less than 2 is not unusual at all. Okay, so remember the tax return example we did in class? So it would be, you know, not unusual at all for one single tax return to be off, but for a whole big group of them to be off, that would be more unusual, right? So that's kind of why we're getting different answers there. All right, let's go to 16. 16 is really, really similar. I think 17 actually is too. Well, actually 17 is a little different, but 16 is really, really close. So the first thing is we can use the normal distribution since 75 is bigger than 30, right? So we need to find the new sample mean standard deviation, which is 0.92376. So part A says, what's the probability that the mean is more than 13? So it's important. Both of those words I underlined are important. So value minus mean over the standard deviation we found of the sample mean. So that works out to be 5.84. Oh, hang on, I'm doing the wrong one. 13, where the heck am I at? Sorry, this is not right, because it should be negative, right? So this works out to be negative 3.25. So it's 1 minus 0.0006. Okay, because it's more than, we do 1 minus, which is pretty likely 99.94%. The probability that we're between 18 and 20, so we just need to find two z-scores. So here I got 2.17, here I got 4.33. If you read off the chart, you're going to get these two values. Subtract them, and you get 0.0149. Find the 10th percentile of the sample mean. So the closest to 0.10 is 0.1003, which goes with z equals negative 1.28. So it's z-score equals value minus average over the mean standard deviation. So cross multiply and then add 16, and you should get what's on the chart, which is 14.82. So D and E is another pair of questions where you're asked about the mean versus an individual. So a mean greater than 19. So that would be 19 minus 16 over 0.9238, which is about 3.25. Okay, remember we're going greater than, so you got to do 1 minus 0.9994. So yes, unusual. Okay, but part E switches to an individual have being greater. So the only thing that changes is the standard deviation you use the original standard deviation. okay, which was given to be 8. Notice when the z-score goes down, it becomes less or more likely, rather. So it's 1 minus what you read from the chart because it's still greater than. So you end up getting 0.3520. So no, not unusual. Okay, so make sure you really pay attention to those wordings of those problems. All right, so moving along. Number 17 is a probability question. Notice there's a percentage given. That's how you know it's kind of a different kind of problem. So the first one, is it appropriate to use the normal distribution to find the probability that 20%, okay, of the individuals in the sample are government employees? Okay, so I don't know if you remember this, but this is where n times p needs to be greater than or equal to 10. And also n times 1 minus p needs to be greater than or equal to 10. Okay. So here the answer is no. Because if you do 0.20 times 10, you get 2. And sorry, that shouldn't be times 10, it should be times 50. Okay. So 0.2 times 50. Sorry, not 0.2, 0.16. Which is less than 10. Okay, so the answer to part A would be no. Okay, so then they changed the sample to be 90 instead of 50 because basically 50 wasn't enough. So now notice if we check it, it works. So if you do 90 times 0.16, it's greater than or equal to 10, and so is 90 times the opposite. So we're good to go, in other words. Okay. So that means we can proceed. So we need to find the z-score. So it's 0.20 minus the average over the standard deviation. Okay, probably should mention that I need to find that standard deviation. Remember, off to the side, remember that the mean of the p-hats is just going to be whatever was given. But the standard deviation, you have to do a little work to find. So I probably should have done that first. And the formula for that is percentage times 100 minus that percentage and then divided by 90. And so if you work that out, you end up getting this 0.0386 that I'm using here. Okay, so kind of an aside there. So this works out to be 1.04. Okay, since it's more than, we'll do 1 minus what we read from the chart. So we get 0.1492. Part C says find the probability that we're between 15 and 18. Okay, remember we're expected to be 16. So 0.15 is going to give us a z-score of about negative 0.26, whereas 0.18 is going to give us a z-score of, sorry, let me move my page up. It's going to give us a z-score of 0.52. Read both of those values and subtract them. If you're doing the review and you get to the point where you're like, okay, like I've seen a problem like this over and over and over, then it probably means you know it well enough. Okay, I did tend to put kind of a lot of practice on the review, so keep that in mind. All right, D, the probability that less than 25% of the sample, so this is the sample, right, which is a different question than part E. So let's find 0.25 minus the 0.16 over the 0.386. It is less than, so just read whatever you see on the chart. Okay, so we get 0.9901. And then I kind of misspoke. This one still is talking about the sample. So would it be unusual for the proportion to be greater than 0.25? Notice there's no need to start over. You already did less than 0.25 here, so you can just do 1 minus that. Notice the z-scores would all be the same, right? So you'll get 0.0099. So yes, unusual. Anything less than 0.05 is unusual. Okay, so let's look at number 18. A sample size of 64 was drawn from a population whose standard deviation is, so the first thing you need to do is, yes, it's big enough. So the first thing we need to do is find the new standard deviation. So it would be original standard deviation or standard deviation of the population over square root of the n. So we get 3.0225. Okay, so the margin of error, remember that is where you look at your chart. So this is where we start using a 0.33. So the margin of error is going to be whatever we find from our chart and then times this number we just got here. So what goes on the chart is you look for a 95% confidence level. Okay, notice the very last row of the chart gives you 1.96, so that's the one we'll use. So it comes out to be 0.5924. Okay, so this is the error that we would add and subtract. Notice this one didn't really ask us to do that. And so the next question says, if the confidence level were 98%, would the margin of error be larger or smaller? So you can either figure that out, but it would be larger because the critical value is larger. In other words, if you look at 98%, what goes here is actually 2.326 instead of 1.96. So yes, it would make a difference and it would make it larger. Okay. If you get stuck in the test and you're just not sure about those conceptual questions, you can always figure out what it is, like actually figure out what the margin of error for 98% is, and then you would notice that it's bigger. So you can do it that way too. Although, you know, you want to save time where you can on the test. Okay. Number 19, so again, let's find the standard deviation of the sample. So that would look like 6.8 over the square root of 80. Okay, so this one, I'm asking you to go a little further, right? I'm asking you to come up with a confidence interval. So what you want to do first is you want to find your error. And your error is equal to, for 90%, look on your chart, it's 1.645. And then you're going to multiply that times the 0.7603. Okay? And then whatever you get there, that's what you're going to add and subtract to the value. So let me get out my calculator and figure that out. So the error looks like about 1.2507. Okay, so that's what we're going to add and subtract. This is the error that we're going to add and subtract to our mean. Okay, so you're going to take 40.41 plus or minus this 1.2507. Okay, and if you do that, you get something between, I think I listed it kind of in interval notation, but between 39.16, if you round it to 2 decimal places, and 41.66. Okay, part B says, if the population were not approximately normal, would the confidence interval constructed in part A be value or of value, or would it be valid? And the answer is yes, since the critical value is the same. Okay. Okay, number 20. We just got a few more to go. So construct a 95% confidence interval. So I'm just going to do it kind of in one fell swoop. So here's what we expected it to be, give or take something. Okay, and how you find that is for 20A, a 95% confidence interval, the critical value is 1.96. And then we need to know what the standard deviation of the x bars are. So we still need to figure that out. So it's 0.41 divided by the square root of 150. So we end up getting this. And so we end up getting between 1.25 and 1.39 for part A. Okay. Part B says if the sample size were 100 rather than 150, would the margin of error be larger or smaller? And then explain. Okay. And the answer is it would be larger. And again, if you have to figure that out, figure it out to actually figure out why that is. But the reason is because this would be larger. Your critical value actually doesn't change, okay? But when you find your new standard deviation, you would be dividing by a smaller number, essentially. So it would make your standard deviation of the means larger, okay? Part C, if the confidence interval were 98 as opposed to 95, would the margin of error be larger or smaller? We already answered this question above, but it's larger because the critical value is larger. So notice here, if we make either one of these numbers larger, it's going to make the overall value larger. Okay, that's all that's really asking. And then part D says, based on the confidence interval constructed in part A, is it likely that the mean is greater than 1.25? And the answer is yes, right? The reason it's yes is because we thought it would be between these, right? So I'm going to say that falls in the given interval. Okay, so we would expect it to be in the interval, so yeah, we expect it to be bigger than 1.25. Okay, so 21 is where we start with our standard deviation of our population being unknown. Okay, that's significant and it's important because it changes what values we look at. It changes what chart we look at, for that matter. Okay, so notice in 21, they never tell us what sigma is. Okay, they do tell us that x bar is 9.6, and they do tell us that the mean of the x bars is 14.1. Okay, but they do not tell us the standard deviation. Okay, so in fact, the standard deviation, and this is actually wrong. This is the standard deviation of the x bars, right? Sorry about that. Not mu, but standard deviation is 14.1. Okay, which means when this is true, you have to use the t distribution, where you figure out the degrees of freedom and all that jazz. Okay, so you do need to remember that degrees of freedom is one less than your n. So we would want to look at 45 degrees of freedom. Okay, notice that on our 8.3 chart though, there is no 45. So when that happens, you just bump up to the next one. So we're going to bump up to the next one. Notice we have 40 and then 50, so we'll just bump up to 50. Okay, so for part A, we want to construct a confidence interval. So it would be what we expect it to be is 14.1. Sorry, we need to change something up here. This was actually the mean. Sorry about that. This is the mean. 14.1 is the mean. The standard deviation is this one. I knew that seemed weird. Okay, so sorry about that. So just go back and change these original things. Okay. Okay. So we want to take 14.1 plus or minus something we find in the chart. So this is where you look at the t distribution. But then you're still going to multiply that times whatever you get for your value here, okay? So what goes here, remember, is going to be this over the square root of 46. Okay, so you'll want to look at your formula chart to kind of familiarize yourself with what we have there. And you'll want to look for things that look like t-score. Okay, and the t distribution, you look at the 50 degrees of freedom, and you look for the proper percentage. So here's 95% confidence, here's 50, so you're going to go up to 2.009. Just kidding, not 2.009, is it? No. 90%, sorry about that. So at 50 is 1.676. So I was doing the wrong percentage. And so if you do that, you're going to get between 11.7 and 16.5. Okay. Notice on the key I wrote it in interval notation. You can either do that or you can write it out in words if you don't like interval notation. That's fine with me too. All right. Part B, based on the confidence interval, is it reasonable to reasonable that the mean percentage of fake Twitter accounts is less than 10? Okay. It's not reasonable since it's not in the interval. In other words, 10 is not going to be expected because we were expecting something between 11.7 and 16.5, and 10 is not it. All right, 2 more questions, and then we're done. Hallelujah. Okay. So let's look at what we've got. Again, this is a student T because sigma is unknown. If it doesn't mention sigma and it mentions the sample standard deviation instead, then you are not able to use a normal distribution. So here's what we know. We know X bar is 16.51. We know that the standard deviation of the means is 0.95. Really, this is actually S. Okay. All right, so 95% confidence interval, so 16.51 is the expected. And we're going to add and subtract. You look at your chart, okay? So we're going to need, N is 77. So we need 76 degrees of freedom. I'm going to abbreviate that DOF, okay? Which means we're going to, again, need to bump up. And we're going to bump up to 80. Okay, so if you look at 80, that's what goes here. Okay, you look at your student T distribution, and you'll get 1.99. And you're going to multiply that times your S over the square root of your N. And you're going to get between 14.34 and 18.68. That's what we're going to expect with a 95% confidence interval. Okay. If a sample of 50 children had been studied instead, so notice the only thing they changed was N, would we have a wider or more narrow, so this was part A, would we have a wider or more narrow confidence interval? And the answer is wider, because the margin of error would be larger. So again, if you want to, go ahead and figure it out for 50 and you'll see that this widens out. All right, so 23 is a doozy. Okay, it takes a little bit of time. Notice N is 6 here, and notice the difference between this one and maybe another one is that I don't give you some of these values. Okay, I actually don't give you any of them. So first you have to find the average. Excuse my dog while he drinks the loudest that any dog has ever drank before, but that's what he does. So you would take the sum and then divide by 6. He's really thirsty. Okay, so we're going to use this value, and then we're also going to have to find the standard deviation. Okay, actually S. So remember the formula for standard deviation, we did it earlier on, is going to be, actually we didn't do this exact form. It's going to be value minus mean squared plus next value minus mean squared, and then all the way, figure it out all the way, and then you're going to divide that by n minus 1. Okay, so this will end up being 0.8377. So I'm circling these because we're going to need them in a minute. So the hard part here was you had to figure out these two. You weren't given these two. And then it's just like the other problems. So the 95% confidence interval would look like what we expected was the mean, but then plus or minus something that we get from the chart times what we just got for the standard deviation over the square root of n. And what you get from the chart for 95%, by the way, there are 5 degrees of freedom for this one. Okay, so 5 degrees of freedom is pretty high up on the chart, and you should get a value of 2.571. So what we end up getting is between 19.50 and 21.26. And then lastly, would we expect a value greater than 21%? Notice it says maybe greater than 21. 21 is still in this interval, so this is a yes. So I'm just going to say it is in the interval. Okay, so the biggest difference between 23 and 21 and 22 was you had to actually do quite a bit of work to figure out the mean and then the standard deviation before you could even begin to do this stuff. So remember, when I ask you to find a confidence interval, it's always going to be what you expected plus or minus some quantity. Okay, and that's what you have the formula chart to kind of remind yourself on what those formulas are.